Are you subscribing?
Oh, yeah. Yeah, bro.
Because we're live now, so you better be subscribing.
What do
uh,
you mean?
I'm just saying, like, you better be subscribed to it. Like, if you're on the podcast, you need to at least be subscribed. You know?
Oh, dude. No, I'm definitely subscribed. Yeah. Yeah, it looks good, man.
Is it actually going?
Yeah, yeah.
It's so
Looks live
amazing.
to me.
It is. Yeah, you're probably about to like.
You got your nice,
Oh,
actual real brick background going.
yes, it's definitely, absolutely, 100% real brick. Definitely,
I gotta
definitely
get the
not a
webcam
curtain.
going. I gotta get the webcam going so you can see my real brick, man. Maybe next time.
I don't know if you're being sarcastic. I thought your room was like
No, no.
white.
No, no. No, man. No. No. You seen the brick behind my
uh,
desk.
yeah. Oh, yeah. Behind the desk,
I'm just gonna have to, like, turn
shoot the back of
myself
your
around.
head.
Yeah. That'd probably
uh,
be the better way to see me anyways.
yeah. No, well, that definitely wouldn't be my best. Like, despite how ugly this is, the back of my head's even worse. Anyway, so this is our first live stream, um, and I called it the AlphaCast. And so, like, if you've watched any of the streams before, any of the channel, like you know me, I'm Jason. But one thing that you might not know is I'm one of the owners of a. I guess we're small right now, wouldn't you say? A
Yeah,
small up and coming integrator uh, automation company. But I'm here again with Brandon Hughes, who is one of the other owners, and we've been talking about doing this for a little bit, just kind of sitting and chatting and talking about kind of automation and different stuff. I forgot to turn on my little light, so Kiki doesn't come in here and bust up in
oh,
here.
yeah.
Yeah, but yeah, so this is our first podcast. Brandon Hughes is on here with us. I haven't quite figured out the best way to display uh, display all that. I mean, maybe eventually he'll get a webcam so we can like see you instead of just like hearing you, right?
Yeah, yeah. Yeah, yeah, we'll get one for the next one set up for sure.
Yeah. But what I want to do this time, other than just kind of like testing, just wanted to talk a little bit, kind of casually about some of the stuff that we got going on. Um, let me see if I can get. So first thing, like I just wanted to talk a little bit about yourself. Like if anybody's been on the channel, they kind of know a little bit about me. So tell a little bit about yourself, and I want to see if I can uh, get some things pulled up here on the backside.
Yeah. Yeah, so as, Jason said, I'm Brandon and, been doing automation for about 6 or actually, I guess it's been probably close to 8 years now, including the time I did it, while I was in college. And yeah, so we started this company and then we just started. I went full time at the beginning of the year and we've kind of been picking up from there. Got a lot of projects going on and stuff. And like Jason said, we're still small, but sometimes it feels like we're very large with the workload we got going. But I'm sure anybody in this business right now kind of feels that same pressure. A lot of work going on in the automation industry right now. So
Yeah, it's kind of weird. You you say that because it's like, um, you say that because it's like the the everybody everybody seems to just be completely covered up if they're doing any type of work, and they're out there looking for help and looking for people. And like I, I don't know if any other industry is where automation is right now. um, and it just seems like no matter what, if you want to be in something that's growing, this is the type of where you want to be. uh, Hopefully Alpha will be a company that can be kind of like a model for what you would actually want, and not one of like a, I don't know, like a boom and bust sort of thing. But
yeah.
we're setting up a pretty good team. So yeah, so say again how many years you've been, so I always forget because
Yeah.
I'm so
Let's
old.
I honestly forget too. I think it's been probably like 8 years since I started working with your dad and stuff.
Yeah.
And, you know, did that in college for a couple years, and then went to a company here local and worked there for 6 years, and then now, yeah, we've been doing this for just about a year now, just full time. But um, I kind of specialized in ignition a good bit when I was at my other job, and so have kind of translated those skills over to what we're doing as well. And then, we do it all. We do everything from panel building all the way to programming and commissioning. So we all get to get our hands in a little bit of everything, but kind of my specialty lies in the ignition software system.
Yeah, tell a little bit about that, because I mean, most of the people that are on this channel are probably here because of the Siemens, the Siemens programming, Siemens PLCs, and tell a little bit about ignition and just kind of your experience between what you see its capabilities are, and kind of like core design, and then where you can take it to.
Yeah, so I mean, we've been, really getting into it here lately with some of the projects that we've done, just as far as like data collection and stuff. But there's a lot of stuff we're working on. I mean, obviously we've got several MES style apps we're doing that are like um, inventory management, project management, that sort of thing that we're trying to kind of integrate ignition into as well. But the biggest thing really that we've been doing here lately is data collection, and I know a lot of that's helped you out a good bit on the Loda project that we had. One of the projects. I don't know. Have you shown any clips of that in any
No,
of your videos yet, or is that just you've
I
been mainly using Wonder?
I think one of the I think one of the I guess the blocks are um in about the like what's it called, the read record and write records, where we're pulling all the data from uh those like ET200 starters. I think a little bit of the code is in there just from some of it. We haven't I've got I just shot a video that's based off of the Loda project that has a lot more into it. It's about that SIP communication block with Alan Bradley. Um, but
Yeah,
yeah, we haven't done any, or I haven't done anything about the ignition portion of it. Uh, just
yeah.
because honestly, I you,
Well,
you
I know we
handle
kinda
it.
talked about yeah, I know we kinda talked about maybe me shooting a video, and we'll kinda gauge the interest in that, and maybe start uploading some of those as well, just certain things like how to do things. I know, uh really up until we went and I started integrating our PLCs into ignition, I hadn't done a whole lot with Siemens. And I know there's a few quirks here and there that we ran into, certain things like even in the PLC you have to enable that if you're doing it for the first time, you might not realize. So we could maybe do some videos on simple setup and even get into some more advanced things with it.
Yeah,
Kind of just gauge the interest there.
I definitely do want to go through and learn that, because that that's definitely one thing that I have seen that I want to learn is just about the ignition, because it's like you're at such a your experience level so much higher and all of that, that I feel like you the stuff that takes you like 5 seconds to do, like I should be able to do and like take it. So uh but yeah, we definitely
Yeah.
would should do a stream about that, because um I, just from an outsider's perspective, see that as like the next level. It seems like what inductive automation is doing with that platform is stinking cool. It's kind of like they just give you the keys to the kingdom, and if you have a little bit of programming experience, then you can really take it. Would you say that that's kind of I'm on
Yeah.
or off on that?
Yeah, I always kind of explain it to folks as like a sandbox, more or less. That they give you all the tools you need to kind of build the web pages and apps and stuff, and then yeah, just you get a little bit of programming experience, and you can do just about anything you want to do with it. So they've done a really good job of building out that platform to be whatever you want it to be. So but yeah, I think that'd be good. We kind of talked the last time I talked to you about how there's a few things that aren't even out there. Certain specific like setup videos, like we talked about the MySQL thing. Getting it set up and working with ignition. Now there's documents, but there may be a video buried, but just initial search results, there's not a
Mhm.
whole lot of stuff like that we might could kind of hit that area too and post some videos on certain things that might help people get their projects moving and stuff.
Yeah. Have you used any other SCADA platforms, or I mean, I know you've worked with the comfort panels. Have you used any other kind of like HMI software?
Yeah, so that was kind of the biggest task I had at my previous job was we had Wonderware, we had Orchestra and standalone InTouch throughout the plant that was running on PCs that the IT department wanted to manage, and we had to constantly upgrade. And it was like every year or two we were having to swap those PCs out, and then having issues with them. You get called at night, have to do a full upgrade on a PC. So we kind of went to Ignition to get rid of all those and get rid of the PCs on the floor. So what we actually did mostly was we did Ignition for any of the data displays and stuff like that, and then we put um, actually Seymour's, like Automation Direct Seymour's on the plant floor. I know you love Automation Direct stuff. Yeah, yeah. So that's yeah, the biggest I've had experience with a lot of them really. I mean, just about all of them, even the panel views, which I'm not a fan of at all, but you got to work with what you got. So,
Do
the
you
Allen
com-
Bradley panel views.
from compare Wonderware to Ignition, because I'm sure that there's, I mean, some people may know the history behind the two companies, but like
Yeah.
just from your experience, I mean, do a little bit of a comparison.
Um like Stone Age to like, future tech basically. No, I mean,
Don't hold anything
Wonderware was
back, man.
Wonder, no, 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 Wonderwear was great. I mean, for its time period and everything, like
Mhm.
it was great. But I think what happened is just they got sold a lot, and then we kind of talked about this that the original like programmers and coders that were improving it, they left a lot of them, and then or got ran off or whatever, and it's just like kind of they just were adding stuff on top of code that wasn't optimized, and they just kept adding stuff and going up on pricing, and it's almost like at the point now where they're just trying to bleed whatever they can get left out of the company, and they're not really adding any major improvements that I know of. And it's really clunky, it's hard to use, whereas Ignition, they're adding actually easy to use features, deploying and stuff like in Orchestra. If you go to deploy something, well, you've got to, I mean, if you make a change in like a template level, you got to deploy it to all the children. Whereas Ignition, you hit save and it automatically updates anything that's out there running that app. So it's like it's a big difference. And then the fact that kind of the way we've been doing a lot of things is using Ignition more for like display versus using it for control. So I
Mhm.
think we're going to do a little bit of that with this new project, but it prevents having to have computers on the floor, which that always causes issues in certain environments.
Yeah.
Having Windows PCs or any kind of PC running an operating system like that, like um, it's not always the best for a machine environment or an industrial environment as some of the dedicated panels like the comfort panels and stuff like that are. So
Yeah.
um, but yeah, that we were doing a lot of control with Wonderware, and then yeah, when you're trying to control something, and then the PC reboots on its own, and you got to wait 30 minutes for it to update, and you've lost control of your machine, and yeah, that's not always a good thing.
Yeah, that
So
that sounds kind of like a nightmare. That sounds like
yeah,
some of the worst experiences that you could you could get.
yeah, exactly.
So in I we talked about just kind of randomly talking about Ignition a lot. I'm super excited about Ignition. It seems to me that's like um the it's leveraging, and correct me if I'm wrong on this, it's kind of leveraging more of the kind of modern web features that kind of have built-in stuff to where it's more easily integrated into like a web browser, or what are the two platforms, the difference between the two kind of vision platforms? Can you explain the difference between those?
Yeah, so they have what's called Vision, which is client based. So you actually would download and install their Vision client. That is more geared towards use as far as like HMIs. what you'd have like on a machine, controlling a machine. The Vision like software package, it basically has a lot of integrated features that make it easy to do stuff like press a button on a screen and that toggle a tag state, stuff like that. Whereas Perspective, you can do all that. You have to do it a little more in depth with scripting and stuff. You don't have just like a straight up tag where you put it on there and then you can toggle it. Not that I know of. I haven't done a whole lot with that lately. They may have added some stuff here recently, but as far the biggest thing is Vision is more geared towards machine controllers. Perspective is more web browser based, and that's uh, I didn't mention that, but Perspective will run in any web browser other than what is the Internet Explorer, which who uses that
HTML5.
anymore,
Yeah,
anyways.
yeah. I think you have to
Yeah.
have HTML5 capable or something like that. And
Yeah, so Perspective will run basically on any web page, and that's the nice thing about it, especially for doing data displays and stuff like that. Basically, if you're in a plant, you've got a server, your upper management wants to see a web page or some data or whatever, throw it on a Perspective page and send them a web address, and all they do is go to the web address, and there it is. They don't have to install anything. You don't have to go down there and install anything. It just makes it really easy for people to see stuff and that sort of thing. But yeah, that's kind of where the two are different. But yeah, Vision is more geared towards machine control, I would say.
I got you. I got you. Yeah, that's like I said. I'm super excited about it because I mean, I'm not gonna lie. Like the first projects that you were kind of showing me the capabilities of it, because I'm thinking like, oh, this is just gonna be, this is just gonna be like a what's it called, like another software package that an HMI system. And I mean, you could do some pretty cool stuff with like comfort panels and things like that with scripting and kind of moving data around. And but the the first things that you were showing me, I was just like, holy crap, this is more of like soft, like .NET style stuff, and you're doing it on a platform that's like designed for industrial automation, and that was kind of cool about that. Seemed like it was in, if you had a decent foundation of scripting or programming languages, like higher level languages, you could kind of actually get a little bit of a, I guess, boost up. You weren't having to worry about those GUIs and that side quite as much. Um, just a little bit. We've got a system that Brandon is developing for us to help us with all of like the shop that we have. That uh, every time I go on there, I click and I'm just like discover a feature, and he's like, "Oh yeah, I did that just like super easy," and I'm like, "Dude, this is freaking awesome!" Like he's like, "Oh yeah, I just thought I'd throw that in." Like pulling up web pages, double clicking on inventory items and stuff, and I'm just like, I totally forgot you did that. I need to actually use this.
Yeah,
uh,
yeah, that's what you said by accident. You found that you were
yeah,
trying to copy a part number or whatever,
yeah,
and
yeah.
that
I was
took you to where
literally
you were
trying
trying
to
to go.
copy a part number out of this little inventory list, and I was like, it. I just was not clicking it right in order to like select it, and then I end up double clicking it, and it just pulls up the web page that I wanted. I was trying to put it into Industry Mall, and just to
Yeah.
look up a price on it, and oh, it just pulls it up and shows it. And I'm like, oh well, I feel very smart now. I'm glad someone else is in charge of this. But no,
Yeah, yeah, but yeah,
yeah,
it's really neat the things you can do, like you were saying. I mean, really, Ignition just makes it easy to build the front end, and if you've got any kind of coding experience, now everything in Ignition is it's Python, but they use Jython, which allows you to use some Java libraries within Python syntax and stuff. So there's a lot you can do, and if you got a little bit of database experience with SQL databases, then yeah, you can do just about anything you want within Ignition.
that's awesome. That's awesome.
Yeah.
So kind of shifting a little bit, um, what was your kind of PLC experience like coming into this? Because I mean, just so y'all know, Brandon is a gold certified ignition integrator, and so out because of that, our company Alpha Industrial Technologies is a gold certified integrator in the state of Alabama. So um, that that is definitely his forte, and I call you a power user on that for sure, like expert user. Um, in terms of your PLC experience, what kind of do you have? PLC motion, kind of like general automation. What do you have there, and where are you in all of
So we we had a lot of everything really at the plant I worked for. I guess as far as like motion and stuff goes, the biggest systems I worked on that had motion and everything integrated was the Omron, the newer NX and RX like well the NX servos, and then we had some of the RX VFDs, but we did a few applications with integrated. It was a 2-axis system, and so that's kind of the main motion. And then we actually did a lot of our motion within the drives themselves. We were using Epsilon drives with control techniques. I think they're NEDEC now. I don't know. They've been sold so many times
that?
that I can't ever remember which company owns them at the current period. But as far as motion goes, that's kind of my experience with motion. And then PLC wise, pretty much everything. I mean, Omron, Alan Bradley, Automation Direct, your favorite, and we had a few Siemens things. I didn't really get into a whole lot of Siemens stuff out there until here when I went full time. Really got into it with the Winder project, which I know you've been using a good bit with the videos you've been doing as far
Hmm.
as showing off some of the blocks and stuff. And that's kind of the real. That's the first time I've been exposed to a whole lot of the Siemens motion instructions, and which they're all the blocks are the same mostly throughout different manufacturers, but got to see kind of how Siemens has everything set up. And yeah, I think so far it's been my favorite. I know you'll be glad to hear that. So
Yeah. Yeah, definitely so. So I got a chat came in talking about WinCC Unified versus Ignition, and I don't know if you're familiar with the WinCC Unified product line. Um, it sometimes some people, I guess, try to think of it as similar to the comfort panels. And if you're familiar with the Siemens product line, WinCC has been kind of their um, overall product. So you back in the previous panel generations, you had WinCC Flexible, which was for the MP panels and OP panels, and that was the software for that. Um, and then inside of Portal, you have WinCC, and it has the comfort panels. And I guess it was probably, I want to say two or no, no. It was probably 2020 because I was still working for Wesco for sure. But they really started introducing this WinCC Unified panel, and it is a Linux based panel, whereas the WinCC comfort panels are based off of Windows CE, and so they started pivoting over to this different system. And from the very limited experience that I have seen with WinCC, it has a lot of, or sorry, WinCC Unified, it has a lot of those capabilities, um, but it it seems to be a little closer to what I expected from out of just like a regular HMI product. Um, the thing about the difference that I have seen, um, and again, I have very limited experience with WinCC Unified. Um, we actually have a unified panel sitting in the shop that we I don't even know if it's open. Uh, but the biggest thing with Ignition is it's almost just a straight open database. We were talking earlier about even being able to use MySQL, so just open source database solutions for that. And I mean, from what I have seen in Ignition compared to what I've seen in WinCC, there's there's not really a competition. One of the biggest things that I've seen, and this there might be a way to deploy Unified on kind of like an on Logix panel PC, is Ignition, you can deploy it. Correct me if I'm wrong on this, Brandon. You can deploy it on anything or any platform that can have a database. So like there's different distributions of Linux and Unix and like all these different open source platforms that you can use. Um, but I don't know. One of the biggest things, and it's still kind of a problem, is actually getting a hold of HMI hardware. Um, and the unified panels are a little bit better because, again, they use the Linux based hardware. But with the Ignition platform, you can you can just use. I don't know. Are you familiar with the OnLogix, Brandon? The panel
We
PCs and
that's
IPCs.
we Yeah, so I know we've got that one down
Hmm.
there. As far as like ignition goes, it's really kind of you can do it in two ways. You can either run the gateway and actually have instances that are hitting the gateway, and then you can also have where you have the standalone ignition apps running. Which if you just had like a machine you were selling or a machine you were doing, and you just wanted to have an HMI that could control the machine and do that sort of thing, you can just run that standalone Ignition Edge on something like an OnLogix. And now, as far as the database stuff goes, like you could run Ignition without even having a database. Realistically, I mean that the database side of it's just for when you're wanting to historize stuff or store data, whatever. As far as like real time control, real time values, you could basically run it on anything.
Okay.
So, but
Yeah.
yeah, that's sort of like on logics. If
Hmm.
you were just wanting to run a single instance, Ignition Edge, they have a license that you could do that sort of thing with. Which in our case, we've been doing everything with actually running an Ignition gateway, so having the whole server and then basically deploying apps off of that
Hmm.
server. But yeah, there's multiple ways to kind of tier it out.
Yeah, probably the biggest advantage to using I guess WinCC flexible or not flexible. Oh my gosh. If you're using WinCC flexible, you're in trouble. Those panels are way out. You can't get them anymore. Um, Using WinCC Unified is the fact that it'd be built into Portal, and it is not your standard WinCC engineering. It is WinCC Unified engineering, but it is still built into Portal. And I'll I'll talk about a lot in my videos that once you actually start utilizing the advantages of Portal, um, you realize that it's really the only way to put it is just like it's so much easier just to drag and drop, and the you're not having to worry about creating tags and things like that. And now, Brandon, in our or I guess in the videos that we do later, uh, you'll I assume you'll go through kind of like easier ways to set up tags because every time
Yeah,
that
yeah.
I always ask Brandon and be like, hey, we need this new tag linked to one of our servers or one of our projects. I mean, it's just done automatic, like it's just quickly, and so
Yeah,
um,
we can talk about. I know we've kind of come up with a good way to structure our data blocks in Siemens so that we can kind of translate that to a UDT in Ignition, and basically in Ignition you get the same structure as your data block, and all you're doing is inputting a data block number on Ignition, and then you know we, that's pretty much it. As long as it's the same data type structure within that data block. Yeah, we can kind of talk about how we've done our things and kind of good practices just when you're building your PLC project. If you're wanting to integrate with something like Ignition, just ways that make it a lot less of a headache at the end when you're getting to pulling all your data into Ignition. But
yeah, you definitely bring up a good point there with um, how you structure your data on the PLC side, um, and again, viewers to the channel know that I am not an Alan Bradley programmer at all. Um, but my experience is almost exclusively with the Siemens portfolio of products. And so when it comes to kind of breadth of experience, Brandon has a lot more breadth, and uh, I have considerably more depth of experience with Siemens product, just because I got an earlier start and I've been going around for a little bit a little bit longer. Um, but but yeah, one of the things is if you set up your data blocks and your data on the Siemens side, ignition is it's easy to go about. There's a couple of check boxes that you have to check at the beginning when you're setting up your PLC, and then the PLC doesn't even have to know about the connection for it to be able to work, um, which is which is interesting, because I kind of talked about in a video that I shot today that'll probably be coming out probably later this week, just about the Common Industrial Protocol, the SIP, protocol that Alan Bradley uses. Kind of has the same thing, and it's intended for HMIs, but there's also some workarounds and stuff that you can get, by using that. But but yeah, the 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 cool thing about I guess the cool thing about Ignition is just its total flexibility, and integration with Python. I think is a little understated. Uh, I don't know how deep that can go with it, but I personally hope that we can use that in some way on the data side, because I think that's where everybody is going with all of automation. And if you don't if you don't set up from the beginning your new projects in order to be data centric and have data access and have a plan for the future for your data, then you're kind of setting yourself back, because the tools and stuff that are coming out now are just kind of crazy. Uh, like with all of the I guess the data analytics that you can do either in the cloud, or now they're coming out with like in-rack data analytics and in-rack AI, like neural network AI. Um, you need to, just from a programmer perspective, from the very beginning, have a plan for your data. And it's funny because like at Alpha, we understand explicitly how valuable that data is, because you can go through, and if you have enough data, especially in Ignition, because it's so easy with the data historian to just plot stuff from complete opposite ends of the plant, and then all of a sudden you're correlating things together, and you're saying, oh hey, I can tell that this is happening, and then you can make adjustments on the other side. Invaluable. Like, just it's like a MasterCard. It's priceless. And so, but yeah, if you're not doing that, then I guess, you're you're setting yourself behind. One of the things though that I I can recognize non Siemens programmers, or at least new to Siemens programmers, just because of the way they structure their data. They structure their data blocks. They structure the lack of function calls, function blocks, and kind of
Everything in main.
yeah. I don't try to knock people, but it's like everything's in OB1. If everything's in OB1 and it's all in memory, I'm just like, okay, all right. Uh, like I'm just like, can we like eject, like pull eject on this project? I want to run away. But yeah, so when did you start, Brandon? When did you start working with Siemens, and how? I guess from someone with a little bit more experience with Allen Bradley and Omron and these kind of other manufacturers, what are what do you see that I guess Siemens does well, and maybe Siemens could improve on?
That's a good question, honestly. I mean, I think they do well with a lot of stuff. As far as like Portal goes, it's probably the best or the most well-rounded software platform that I've worked in. Um, Omron Sysmex Studio is kind of comparable. They have kind of the all-in-one where you can do your motion, your drive stuff, your HMI, and your PLC all in one software package. Um, and I think I didn't work a whole lot in Studio 5000 with Alan Bradley. Most of our stuff was the older firmware, and we just kind of kept it that way. We did all our stuff outside of it, and we didn't have too many. We didn't have too. We really didn't use any Allen Bradley drives where if we didn't have to. And then as far as the HMIs go, we had a couple, but we did all those outside of Studio as far as programming goes. So I can't speak on that too much, but yeah, I mean, so far I think Siemens has probably been my favorite now that I've kind of really gotten used to using it, gotten used to navigating through it and everything. I'm sure I can't think of anything bad. I know I've probably complained to you. You could probably recall some of the stuff I've complained about. I can't think of anything right off the top of my head, but overall, I think yeah, it's probably been the best one so far that I've used. So
Yeah, so I think the reason you may have a, so newcomers to Siemens in version or Portal version probably uh 13, 14 and on I think have a similar story from what I've heard to what you said there. What what I guess has happened though historically is Alan Bradley came out with originally the first PLC with ladder logic. And at the time, Siemens was essentially using um, technology that was very similar, like VME bus, and it was almost assembly language. And so, a lot of a lot of a lot of older automation people, they have only seen Siemens PLCs written in statement lists, which is essentially assembly language. And if you're not familiar with what assembly language is, oh my goodness, please don't do the trauma of going through and trying to learn it. Like it's horrible. Like Brandon and I both were. I think Brandon, you were probably the last class that had any sort of assembly language at Alabama, right?
I don't know. I wonder if they're still doing that. I feel like they are. I don't know. I know we took microcomputers, and that was
Mhm.
where the class first started out. We were working with little PIC 24s, I think,
Yeah.
microcomputers,
Hmm.
and yeah, we had to start off writing everything in assembly. I don't know if they still do that. I would hope so, honestly. I mean,
Yeah. Yeah.
it's one of those things. It's one of those things that it definitely helps to know, but I don't know of anywhere you would use it nowadays.
Oh yeah. Yeah. I mean, or so I guess though to some degree, like for very low power electronics, to where you have like these extreme low power electronics that are for like the IoT. Um, I guess that's about the only place that I could see there being a need for it because everywhere now, even on like the PIC 32s or even the PIC 24s, the 16 bits, they have really good C compilers that you can program in C. It compiles it down into really efficient code. It has all of these like really really I guess power efficient functions. Um, Whereas it used to be that the compilers just kind of sucked. So it for a little, I don't know if I've ever mentioned this. Like it, Brandon mentioned my dad earlier, kind of teaching him. So my dad started off. He did work on the side for a long time, in this field, and that's where I kind of cut my teeth. And it sounds like a joke, but like the moment I learned to divide, my dad was teaching me Ohm's law because all right, once you know how to multiply and divide, you can do basic circuits. And so I had I had a leg up in that. And so the first projects that I was doing was in assembly language, so I didn't know any better. And it's so in assembly language, you actually have to know the oscillation frequency of the crystal for your microcontroller. So and But because of that, you can write incredibly efficient code wise programs um, that basically run on almost no memory, and you could do some pretty cool stuff with hardly anything. And so, assembly language is the language, like every every processor uses assembly language, and they've each processor has their own languages or versions of their assembly language. And so if you have like an Atmel processor, like in an Arduino, the Arduino compiler compiles it down into assembly language and into the actual machine code that's running the code. Um, and assembly language is as close as you can get to machine code than that you can get. STL, statement list, is doing that on a Siemens processor, and it's always this kind of joke about, I guess, the German way of doing things, and again, it's like a half joke, but I'm a quarter German, so that's the only reason I can I can understand it. So like I've got just enough of that mindset to be able to be like, okay, I get why, but no. uh and so
Yeah.
like a lot of the guys that would be like out where you were working, when I would go in, they'd be like, well, Siemens is just, you can't even ride that, you can't even use ladder. And I'm like, no, we you could do ladder since like 1992. Like but that's just kind of the perception of it, because they'll see all these German pieces of equipment that come into these plants, and they're written by Germans, and most of it's in statement lists because it's just been passing down this code from year to year to year, or from project to project. Because the fundamental difference in I think a Siemens PLC and that German, maybe it's German, whatever, that the difference between the methodologies is portable code. Um, a function block is as close as you could get to um, like object oriented programming in on a PLC, without actually getting into all of those higher level things like inheritance and recursion, like all those different things. Um, but what that means is if you're used to writing a good piece of code that you use over and over and over again, it doesn't matter what it's written in. Like you just use it. You pull it out of your library and drop it into it. And that's one thing that Alpha has really, I say Alpha, I've wanted to make sure that as we grow as Alpha, um, we're efficient with our time. And because that's the most valuable thing when you are in your automation career, is your time. And if you go into a project thinking, okay, I'm going to be efficient overall with my time, you might spend a little bit more time writing a function block that, and troubleshooting and getting it to work right. But then you use that function block 100 times. So we mentioned a project called Loda, and it is in a couple of these different videos that I've put out. Um, and there's 100 or so motors in that plant, and I took the time to write a very robust function block that was overkill for what most of that stuff was doing. But because I did that, Brandon was able to immediately just write a UDT in Ignition and just be able to instantiate one of those UDTs, and it just makes it easier. Um, and going back to the whole like ease of using Siemens versus Allen Bradley, if you are coming into Portal now, that's not the case. Um, and there's even languages now that are higher level languages that I know from kind of the motion control platform. There's a motion control platform called Samotion, and it has a language in it that's ST, and you can use that language um, in um, Portal. And so it is a high level, like text based language, kind of like similar to like a C++. And yeah, its syntax is fairly similar to that. And so those, the capabilities that you get in Siemens is, I guess, I've always kind of like in the classes that I've taught is that um, the difference between, say, like the methodology from traditionally from Allen Bradley and versus Siemens is Siemens wants to give you the ability to do whatever you want to do. Allen Bradley wants to do in as many projects as possible, but they want to make it as easy for you to implement those projects. And for 80% of projects, Allen Bradley is going to be easier to just kind of just go in and set up a project. Um, for say 15% of those projects, um, it's going to be easier for to do it just like in the Siemens traditionally in the Siemens software. Um, and then that last 5%, you're going to have a tough time. Just you're hemmed in with the technology. That's kind of traditionally. Now with Portal, I really think that it is so much easier to, as a whole project, to do these things. Just you're having all of these like .NET features where you'll see in some of my videos where you just start typing in tags and it's pulling up system tags and it's kind of auto populating, and you can populate out a tag that's a fairly complex tag to get, and all you hit is like 5 buttons. You just like L dot B dot and it's just auto populating through just like you would in like a .NET programming environment. Um, but yeah, so I think you hit a good time, if I had to say that, Brandon, for you to pick up, especially with your experience with Siemens, because I think that's going to bring you in, open up your capabilities, I guess, on what you can do. Um, so shifted gears a little bit again. What was your first project that I guess programming project that you worked on at Alpha? Was that the Winder project?
Yeah, I guess so. That would have been the first one that I did, like within Portal and everything.
Mm-hmm. Where would you say? I guess describe that project. I'm gonna get the software pulled up, that actual
Okay.
code, because on this I wanted to actually go through some of it. We've had some people that have actually asked about using motion control technology and how to actually program in it, and I wanted to show some of that, and I wanted to get an experience or get a little bit of experience from someone who is not as familiar as it going into it as what I had. So tell me a little bit about that project, and I'm gonna get this software pulled up.
Yeah, it was at first a bit overwhelming. I'll be honest. A lot of the stuff, obviously, that was kind of my first deep dive into Portal as far as like a big project goes with multiple axes of motion that are not necessarily. Well, I guess actually, yeah, they are. We've got several that are synchronized there, but you know, I guess there's quite a bit going on there at first glance, but the more I looked into it, the more I worked with it, the more it started to kind of clear up and make sense on how everything was working. And I spent a lot of time out there. Just initially when we were getting it started up, I know you spent a lot of time out there as well, and that really helped us, I guess, as far as my understanding and just getting through projects and stuff, and doing stuff like, I guess, running traces and all that sort of thing as well. Just really helped familiarize myself with the tools that TIE Portal had, and that sort of thing.
Where I guess where would you put in the range of projects that you have done in your experience? Where would you put that project kind of like in your experience level?
It's pretty comparable, I would say, with the big Omron project that I kind of helped, complete and stuff at my previous job. It's a little bit, I guess, more. There's a little bit more going on with the Winder, but that's probably the most comparable project I had. Was it was actually a fine wire drawing machine that was taking this rod wire and drawing it down, and you got several axes you got to synchronize, to roll it up on the spool and traverse it to make a level wind and stuff like that. So you got a few things you got to synchronize, but that yeah, I think the Winder is probably the most the most going on that I've actually been directly involved in. I kind of helped support some machines that were that complicated, but never actually helped do any of the base programming and stuff like that.
Yeah. Yeah, so just a little bit of background about this project. The it is a roofing felt winder. If you're not familiar with what roofing felt is in a shingle roof, there's an underlayment that is laid down between the actual wood and the shingle roof, and there are quite a few different variations of that underlayment. And um, in the U.S., there are different states that require different versions of um, this paper. The I guess the simplest version of this paper is just a saturated. It's tar saturated paper, and they come in these giant, like 3,000 pound rolls. They are 42 to 44 inches wide, and they're anywhere from 67 or 66 to 144 feet long, depending on the grade. And the simplest is just a saturated paper with tar and a couple of lines on it so that the roofers can line up their shingles. And then some of the more expensive stuff is has a much more complicated process, um, but it's marine grade, a lot more robust. It has an actual um, sticky backing on it, in order for the underlayment to not be able to be blown up in a hurricane. And so that underlayment is designed for like coastal regions, down in Florida, and so you have where you would have extremely high winds trying to take your material off. Um, and so a few I say a few years ago, my dad many years ago got in with an OEM equipment manufacturer that designed winders that would take off of these roofing lines and and actually and actually um, wind up the individual rolls off of the assembly line and cut them, eject them off into packaging and all of that. And this he actually kind of became pretty well versed in doing this technology, and he was one of the first ones back in the 90s to do convert electric conversions of hydraulic winders. And he actually did um, did the first electric conversions for the OEM that had the patent for the first hydraulic roofing winder instead of a mechanical pulley style winding. And so that's kind of the where my dad was doing this stuff, as I was growing up. He was designing these controls for these OEMs. Back in 2020, we did a new design using Siemens technology objects, um, of his kind of old process. He had a really excellent design for a master drive based winder, and we kind of upgraded it to the new that methodology and kind of started not completely from scratch, but as scratch as we could. and brought it up using the Siemens technology object and using motion controls. And if you go on the channel into playlist, you'll see a lot of technology objects, MC home, MC power, MC move, or move jog, move absolute. Like all these different blocks are all in this program, and that original program was done for a a retrofit of a machine um, out at a plant in Alabama that um, yeah, it set records over 2020, and it there's been a couple of issues that we walked through and we figured out of like how to cut the knife and all this stuff. And so in this past year, we actually took the next step because these OEMs are starting to kind of like exit the market. We took the step to design our own actual mechanical winder using the experience that we've had through the years, um, our partners through the years to design this mechanical winder and then take what we learned from that 2020 winder and implement the winder that we're about to show you. And again, if you've watched the videos, you will have seen this program because this program uses almost every Siemens technology object, every motion control. There are a couple that it doesn't use that are for coordinated motion, like kinematics and camming, but it sounds like a very simple process. But as Brandon could probably attest to, there are some complexities to it. So as I pull up this thing, Brandon, would you mind going through and kind of like what were your first thoughts when approaching a project like this? Because I know you had some like Siemens programming experience, but had you ever worked with the S120 drives or any of the motion control technology or anything like that? What was it like coming into this project?
Yeah, not, I'd done some basic programming and stuff like that, but not anything with the actual motion blocks or any of the S120s until this. So, at first, like I kind of steered clear of that just so I could kind of familiarize myself with the whole process. But obviously, I had to kind of get into that more as I got into the actual commissioning phase of the project. But I think once I got into it, obviously you kind of helped guide me and get me started and stuff, and it came pretty quick. I don't think it took too long to kind of catch on and see how everything was working within the blocks and stuff like that. Um, it's all the blocks are the same across uh different manufacturers, processors, whatever. It's a standard, right? Like
Hmm.
the blocks.
Yep.
Um, so as far as that goes, I'd worked with some of those before and some of the other stuff like the Omron processes that I've done. But yeah, it didn't take too much. The technology objects and stuff, getting into those and kind of figuring out how to set those up and stuff. Which most of those were kind of set up from the get go from what you guys had done, but
Hmm.
there was a few little things we had to go in and change, adjust. But I mean, yeah, it wasn't too bad, really, to be honest. I kind of expected it to be a little more difficult than it was, but
Yeah.
everything was kind of easy to find and easy to use for the most part.
What would you say in this project that was the most kind of challenging for you to kind of either wrap your head around or kind of work through? Because I know there was a lot of things that are preferences and like my dad and I are a lot of are a lot the same in a lot of different ways, but we also have our preferences for things to where we differ on, and
Yeah,
um, there's a
I think
little bit of that there. So what would you say was like the biggest challenge?
I think initially just wrapping my head around what was going on, like without really seeing the thing run, it was kind of hard to understand the whole um, step sequencer and stuff, and what actually everything was doing until I could actually sit in front of the machine, watch it run the cycles, and kind of
Hmm.
follow that sequence through there. Because yeah, I mean, when I first started looking at that, I'm like, oh man, it's gonna be tough.
Yeah.
But yeah, that was probably the biggest thing for me, just upon first look, and then everything else is a lot of motion blocks and stuff like that, which I'd worked with, but didn't have a whole lot of time on, and yeah, so it was just one of those things that took a little time to get used to, but wasn't too bad. But yeah, I would say probably the biggest challenge for me was just getting familiar with the whole entire sequence of it. And plus, I'd seen the other one you guys did run, but like I didn't actually sit down behind the program when it was running,
Mhm.
so I kind of knew how it was supposed to act, but there were several things that I wasn't sure of and didn't even really know until we really sat down and started getting this thing running.
Yeah.
Some of the parts of the sequence that had to happen to ensure you got a complete role and that sort of thing. So
Yeah. Yeah, well, let's take a look and kind of like go through the code because I've had multiple comments about like how to actually implement these motion control blocks because it's one thing to have a block and be able to kind of talk about it and I guess uh know how to use the block, but how to actually use it in a program um is definitely something different. And so um take Brandon, I want you like at any moment when you kind of see, I'm just gonna kind of walk through the way this is laid out. If you take an opportunity to be like, hey, this was something that was either common in your experience with other brands, manufacturers, or hey, this is a a kind of a note if you're coming from another place of how to think about something. Please step in and just kind of like
yeah,
take on
okay,
that because your perspective is I have the blinders on. I'm like I've got 22 years of Siemens experience, and so
yeah,
it's yeah I can take for granted the fact that like not everybody just clicks immediately with this. So
yeah, yeah.
yeah, so one of the things that mentioned in this is the fact that we have a sequencer. And in any process, I was wondering in any process, I might try to pull up a. Hey, will you while I'm talking about this? Will you do me a favor?
Hmm.
Do you have any of your
Yeah.
videos like on your laptop to where you'd be able to stream and be able to put some videos of like the cycles going up there?
We've got them in the media section. Yeah, yeah. We could probably put some of these. I can
Yeah,
pull them up. Yeah.
yeah. I'm gonna talk about it like if you can get one of those behind the scenes, just so we can kind of get an example of like what this process is about because it looks pretty cool and it looks pretty simple, but there's a lot going on. And so as you're going through, there's essentially this paper that is sitting um in our case, we have an accumulator and it's running through and it's trying to kind of do some optimization on it, but on other on other lines, it's it's in what's called a free looper. And so the winder is just pulling this drying paper off this line. And there's a process that it needs to thread up the mandrel, start the wind slowly, and then ramp up to speed, wind, measure out the wind, slow down, make the cut, and it's all these steps. And so one of the things that I've been asked about is like how do you actually go through and sequence all of these blocks? So the first thing that you need to do is to um, have something have something that determines block what block is getting executed, what set points are getting loaded, what functions are being engaged at any given point. And for this program, we chose to use a sequencer because for the most part, there's really two ways that you would be able to, or you could do this. You could use a sequencer or you could use a state machine. And for this, the sequencer works a little bit better overall. You are generally going to have to go through every step every time. Um, and so um, the the thing about the thing about it is if you get out of a step, something happens in the middle of an automatic wind, then you're you're not really gonna be able to recover, or at least there's only a couple of places where you'd be able to recover. And now I will say, brag on Brandon a little bit of this. That those recovery modes are the ones that he worked on especially to implement to be able to detect these problems and to be able to recover and automatically start back up. One of the things about this winder compared to the winder that's the an older style electric winder is that there's a person stacking just sitting there most of the time. He's on his cell phone, like watch waiting for the rolls to like hit him in the back as he's like as they're stacking up, and then for him to put them onto the pallet. One person, whereas the other one has three or four guys that are like crawling all over the machine, adjusting everything, uh and for the most part, if there's a problem on the or the few problems that are on the new winder, the alpha winder, um, it generally just kind of is able to recover from it, take care of itself, and then just get back to running. Um, but part of the sequence is, and the way that the sequencer works uh, for this project is you have a series of steps, and you have a series or a data block that has your sequence steps here. So this step is just an array of booleans, and as the sequence steps through, it goes through the steps pretty simple. And in the logic, you have kind of the conditions that are that are needed to advance to the next step. Um, this is a little bit different than a state machine in its fact of like we talked. I kind of mentioned it. It's like this wants to go from step one to step two to step three to step four, whereas a state machine can have transfers to any valid state. And there could and we have some automatic controls in like our pellet mill control that uses a state machine. And depending on the state of the machine, because it's fairly in its automatic control, it's sitting in a constant state for the most part. And then if something changes, it will transition into some other control state. And that's the difference between a state machine and a sequencer. Now, this sequencer, the only way that you can understand anything about how to step through these steps is to know kind of like the process. And that's where the experience of 20, 30, or I guess my dad's 30 years of experience of working with these types of systems has really come through, and kind of set us up for success in starting from this. Now, using the technology objects, this brought up a couple of issues, and we'll see because, like we mentioned before, we always want to be efficient, and I think Elon Musk has been said on multiple occasions that it's always a good thing to try and delete a feature, like delete something. If you can delete it, then it's get rid of it because it's extra. It's just going to cause you trouble further down the line, and that's kind of a SpaceX principle. Um, and so we always you get these code bases that work, but then you go back and look at it and you're like, oh my goodness, okay, so how can we kind of pare this back a little bit? This is getting a little hard to work with. Um, and so I feel like that as we go through this, um, we that's probably the next step is to be able to take in that methodology, and the improvement on this will be in simplifying the code and kind of streamlining it. Were you able to get one of those, Brandon?
Yeah, I downloaded a few. I guess I can try to stream on Discord or something.
Yeah, if you stream on Discord, I can pull you up. over over on
Yeah.
this other screen.
Let's see if I can get them all up, and because I know I can stream media player, but I don't know if I can have them all up in like a queue. Um,
Obviously, this is our first time figuring out the best way to do all this. So while he's doing that, I'll kind of just talk about the different axes. So there are quite a few different axes of technology objects in this. I'll show you in our technology objects. You can see the different motions here. So you have all right. So yeah. So we'll
I can
watch
see
we'll
that.
watch a couple of these while I'm going through. So hold on. Let me get you up there. All right. Go ahead and play
So
that.
I mean, all right.
So you can see this. This is actually pulling off of this the felt out of this accumulator here, and this is pretty slow comparatively, and cuts, ejects, and so that's the sequence. What you
Yeah, I think
see,
this was running pretty slow that day. I don't remember what the speed was exactly, but
yeah, one of the things about this is you always want to start slow and ramp up your production speed. Um, but in our motor list, this shaft here is called the mandrel. You have your knife, which is the rotating blade there. Go ahead and replay that. Um, and you have your ejector axis that's here. It's the arm that actually scrapes off the ejector. You have what's called an anvil roll, which is a driven roll underneath the knife roll. And then you have a metering roll back in the back that actually clamps down onto the material and pulls pulls the material out of the back system. Now, in this, we have two other axes that are part of this accumulator. You can't really see it very well here what that's doing, um, but yeah. So that's our actual winder and how it runs. Um, so we'll go back down to look at the code. So we see here we have our mandrel, our ejector. Oh, I didn't mention the apron. The apron is just a piece of metal that when you go to thread the material, the apron comes up and the material slides on top of the apron in order to thread into the mandrel. Here's your anvil, and then you have your metering rolls and your knife. And then the accumulator carriage and the pull roll are back in the accumulator, and those are those two axes. Um, so each one of these technology objects has to have a function call that is associated with all of the control for that. So let's pull up the metering roll uh, axis is is the one that in that video is the far back and it measures everything out. Um, and so we'll just kind of step through real quick all of the axes here or all of the data that's here. And so this these like normalizations are just ways to interface in with your HMIs. So the customer likes to be in percent. You have to change between you have to make sure that when they are that when they are actually whatever they're inputting in is actually in percent. And so that's kind of what these normalizations are. Now on the metering roll, there's a couple of different things that we go through, and some of this stuff that you'll see here, if I don't mention it, like these calculate slow down to cut distance, we're using that for other metrics that isn't necessarily involved in the actual control. Um, with with these, there's safety loops, and then we start coming into our MC power and MC reset. And so those are the first two that you always got to get up. And That's why they're together in the video. Super simple. When you're actually ready to operate your axis, you want to be put the MC power on. And so here we have this safety loop, and that's we have this okay to operate, and then an in-feed ready. Because we're using S120s, it's a common DC bus, and so you have to make sure that that DC link voltage is up, and that's what we're doing there. MC power, it just comes on when that power is enabled. This block is enabled. That enables access. We have a system reset, and that resets the faults just over everything, and that executes this reset. Pretty simple. Now you'll see like like we've done. We always try to eliminate code, and we're gonna be real here in stuff. Some of the stuff is like, um, it we're like, okay, was that something that was useful in some other part of the code? And this network 9 here, as you can see, it's named not sure the purpose because when I was going through it, it didn't make sense what was actually going on here. But uh, we we left it in there just to make sure that we didn't shoot ourselves in the foot in startup. Probably should go through and delete that, but I'm not going to do it now because the machine's running. Um, we have NC home, and so you can see here how just to get one home execute on a metering roll, there's quite a bit of complexity in here. And part of this, if you hover over this, because we've named these steps the way they are, if you hover over them, you can actually see that's the ejector return step. You hover over this one, that is the home knife after manual cut step. And so you go through all of these different conditions in order to fire your technology, like your MC home. And for this one, we're always using the home mode as being 0, which is just saying, hey, wherever you are, put in a 0. Um, and that's what this is. Um, and that's our home block. And I go through here, and I will say, one difference between my dad and I, the way that we had operated before, and the way that we are kind of having to learn on the fly as Alpha is growing, is to operate in engineering teams and to be able to kind of like leave your code in a way that someone can come behind you and say, hey, is this right? I need to come and be able to look at this. And so documenting the code, um, documenting code, naming things. One thing that you may have noticed, like these two little the collapse all networks and then expand all networks. Those two buttons are the biggest thing because there's quite a few networks here. But you go through and see like MC halt has all of these different steps, and so you're just going through and determining all of your MC blocks. Let's go down to say a move that we want to actually coordinate. So the way that wind works is at the beginning of the wind. Uh, at the beginning of the wind, the metering roll is lined up and homed, and then you put in your set point for the length of your roll. So if you were running a 64-foot roll, then there will be a conversion from the actual 64 feet, your units, the actual display units, to your engineering units. In this case, it's all degrees. And there's a little bit of an annoyance with that, but because of the knife, we wanted to make sure that everything was lining up and we didn't introduce problems. So because the knife has to be in degrees, the metering roll is in degrees as well. And so there's one of those conversions is from feet to degrees. And so our set point, we set a total length of the length set point. And in this case, it might be 66, 67 feet, whatever it is. And during that one long uh, move, which is a relative move in this case, it does one long relative move. Other things will be looking at that position as it's going along and saying, okay, I now need to be running this metering roll at a higher speed. I need to be able to release it up to 100% speed. We want to slow it down to this speed. We want to slow down, but that's all one solid move. And I'll show you on um, I'll show you on this, like the move that this is setting up is we are trying to, let's hold up. We're trying to set this up to where um, we're doing this one long MC move, and depending on where we are, it has different set points. So in this case, this is a misthread detected, and so that's a completely different set of conditions and set of set points. Here is our setup for thread. So this is the actual start of the roll here. And what we are setting up is a move that, if it was unimpeded, meaning we weren't messing with the velocity override, it would accelerate up to whatever speed is there, run the total out, and then go down at our deceleration. And this total distance here would be, we said 66 feet. It would be 66 feet. That's kind of what we're looking at trying to do. And so our velocity would go up, be completely stable while we're doing that, and then come down. So that's what we're trying to do. And our move here gets executed here. So set the MC move execute. And in this case, it's step 8 is going to be thread. So once the thread setup is done and we have this information over here loaded in, then it's going to start executing this. But, big but, we use what's called the velocity override. And what a velocity override does is, let's see if I can change the color on this. It puts a cap on the velocity. So if this is 100% velocity set point, and we are wanting to cap it off at 50%, it would do this. Now, it would still keep up with the distance, and so we would put in like a 50% velocity override, and instead of going all the way up to the speed, it would go only up here. Well, what we do is in our different steps, we are setting our different velocity overrides, and those are the different steps. So as we go through here, you could see our initial step is the thread step. There's a thread speed set point. Our the next change in the velocity override is the setup for a first wrap. You want to thread in slowly, then bump it up a little bit for a first wrap. There's a reason for this. And then you want to actually go to the winding speed. And so you have these three different speeds. And so winding speed is actually 100% of what you're wanting to do. So your maximum velocity that you're going to allow is here. Your velocity override for this is changing the speeds. And so you set up that set point to be here. And so what this what it would actually look like is be sitting at 0 speed, go up, sit, go speed up a little bit, and then go up, wind, and then come down. And then that would be the overall 66 feet would be here. Because remember, we're doing a move that's based on 66 feet. So that's kind of how this system works. We can clear that, and yeah, so that's what we're doing here. And you can kind of like, I'll just scroll down through here, and you can see all the different places where we are going through and changing our velocity override. And there's a lot of different stuff that goes into these, but for this is kind of the simplest version. The simplest axis is the metering roll. It kind of goes up, runs a speed, runs a distance. um and so yeah, we have other modes. And move jog, same thing. You have all the different conditions that you have for that. Now, one thing that I we're kind of going through, if you notice, there's quite a few different things that you have to go through, and you can kind of like look at what's there on that one. Let's take a look at the mandrel, because I want to go through. Is there, Brandon, has there anything that's like jumped out that like when you were going through this for the first time that maybe you might want to like tell about pitfalls or whatever with these motion control blocks?
Um, I know. I mean, not necessarily. I think we had some issues, I guess, with some of the sequencing things. Obviously everything's got to be in time and in sequence for it to work right. And we had some issues with some of the processor stuff, but with the actual block itself, I don't think I ran into anything really that I can think of.
Yeah,
Not right this minute. There may have been something, but if I think of it, I'll bring it up for sure.
yeah, yeah. That's good. So, um, yeah, one of the cool things, and I think we've had a comment before, kind of talking about a winder unwinder, and in a way, this is an unwinder app or a rewinder application, because we're taking product that's coming from a big roll, doing some stuff to it, and then winding it up into a smaller roll. One of the ways that you get a nice tight roll is by running the mandrel, so that the big metal bar, running that mandrel in torque control, or in our case, torque limiting. Now, the difference between those, I'll try to explain it quickly. Torque limiting, the motor is trying to run at a certain speed, and it is being torque limited to run, and because it's clamped off, it may want to run at a torque limit of, or sorry, a speed of like 100%. But something is holding it back, and it's only running at say 50%. So it's constantly wanting to try and get up to this 100% speed, but it's not able to because it's being clamped. In this case, you have a the metering rolls are sitting there feeding the material in, and say this is running at 100 RPM, and the mandrel is trying to run at, we'll just, 1,000 RPM. Well, the torque limit is set so that it gets tight tension as this starts to wind up, but it's not so much torque that it breaks the sheet. So in torque limit, this situation, this diameter is going to be running up higher and growing the whole time. And so you can either keep up with the diameter and change this RPM, or you can just say run in a torque limit, and just give it enough of a speed, because as this gets bigger, this will have to run at a higher RPM. So you'll actually see the RPM on the mandrel, if you traced it, kind of drift up a little bit in the wind, because as it's getting a little bit bigger, well, actually it's going to go down, right? Because the torque is going to be the same. So as it gets bigger, it's actually going to go down.
Yeah.
Um, but yeah, so that's what we're doing here with the torque limit. You look at all of these steps that we have here, that's when MC torque is going to be enabled. And obviously you're limiting by like a 50% torque. 50% of your torque, or 25% or 10, whatever it is to keep you from breaking that paper. Um, that's what this is. Um, One thing about this torque limiting block, um, and is very important, and I want to talk about this, and this is something that is kind of like a motion control thing, and it's not just for this block, but it has to do with a thing called following error. And if you are not familiar with what following error is, um, in a position controlled system, your position will, if you are running at some RPM, your position set point will look something like this. Nice and solid speed, rise over run, that's going to be your velocity. So however much this goes up, say this goes up from 0 to, say this is 1,000 millimeters, whatever. Doesn't really matter the units. But as it goes up, that is your position. Now, that is if you can keep up with the actual set point. What can happen though? What can happen is, if you cannot actually accelerate as fast as the set point is going, it will look like this. And now it might still get to that same 1,000 millimeters, but it takes a longer time. Say this is 1 second longer to get there. This number, or I guess this gap here, this gap that is constantly building up and getting bigger and bigger and bigger, this gap is a following error. And normally, that doesn't really matter that much, because ultimately, if you're allowed to continue to go, the following error gets smaller and smaller, and once it actually reaches the position, it equals 0. Because here, it's supposed to be at 0 here. It took a little longer to go, and so it's supposed to be at 0 here, so it's at 0, so the following error is 0. No big deal. Well, part of a problem with a position controller is that the position controller is always trying to say position actual equals position set point. So this is the whole point of a position controller. And a position controller is super serious about it's really it's really serious about doing doing its job. And so when we're looking at this, when we're looking at this, the reason I bring this up on this block, MC torque limiting can get you into a lot of trouble if you are doing a position controller. And here's why. Because if your position controller is enabled, it's trying to do that. It's trying to constantly make that. Well, the whole point of MC torque limiting is to make this happen. It wants to hold it back. And if you are in torque limiting, this value will continue to build up, build up, build up. And so no matter how long you run, it's always, 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 always going to be building up a following error. That following error is just going to keep getting bigger and bigger and bigger because it's how it is. Well, that doesn't sound like much of an issue because you're like, well, we're not using a position controlled move. I'm going to show you something why this can get you in trouble. This mandrel move on here that it's in. So like we're using the jog just for reasons. And honestly, when we first wrote this, we didn't understand these blocks enough and kind of got in a little bit of trouble. And this was back in the 2020 winder. This is the biggest thing that we kind of like we were checking, but it caught us off guard. So if you notice here, there is on the jog block, there is a position controlled parameter on this jog block. And it's a jog, it's a velocity jog. Heads up, the look at this, the velocity move, which we're not actually using. Velocity has the same thing, position controlled. And if you notice on this block, the position control is set to true. Big problem. Big problem. So let's go look at this jog block. If that position control is set to true, like up in the velocity, when you are in torque limiting, it will always be trying to catch up that following error, and it just can't because it's torque limited. Well, the second that you turn off the torque limiting, it tries to, as fast as physically possible, catch up, and make that the value of your P actual equals P set point. Even though you've been running in a position control move, it's going to try to run that up. And the first time that we did this, the mandrel, when we deactivated this torque limiting, it spun too fast and it actually wobbled and had a mechanical resonance in it. And we were literally sitting there with our hand over the e-stop because it was the first time we were testing this, and just instant hit, it still spun too fast and bit the mandrel. And so we had to go back and mechanically rework that. So if you are going to use MC torque limiting, and I'm going to put this in the video about MC torque limiting, if you're going to use this block, be super careful so that it is not in position control.
I'm just glad you made that mistake and I didn't have to be the one to call you like when I was commissioned and be like, hey, I'm glad you had already made that one. So
yeah, that was one that, yeah, it. I'm bringing it up in big letters, and circling it because it was a big one. It didn't end up costing a ton of money, but it could have cost lives. Those sorts of mistakes. I mean, it sounds dramatic, but I know we've talked about this before. Uh, so no, so Lucid kind of chimed in on this. You don't need to disable the position control in the technology object. You just need to make sure that you're not doing a position controlled move. So great point there. Uh, the blocks that I brought up, you would think that they're like MC velocity and MC velocity and MC jog. You would think that would automatically be these velocity controlled move, but they have the option to control the position control. Now, here's the thing: there's some moves that you can absolutely use the MC torque limiting in, and it be in a position control move like an MC absolute or MC relative. Those have to be in position control. They have to be on. You could still use the torque limiting. You just can't turn the torque limiting off while you're in the middle of that move, because otherwise it's going to catch up that following error, and that'll happen. So yeah, this was one that like I will forever remember because uh like we even tried to do everything we could to like predict what could go wrong. And I don't know about you, maybe you could speak about this in your experience, Brandon, but for me, the difference between a an automation engineer that makes it and an automation engineer that either gets pushed into some role that to where they can't really do anything is just like it sounds so morbid. I don't know if you do this, but like for me, every time I go to download, I'm sitting there thinking, when I click this button, how is it going to kill someone? And
Yeah, no, I think I'm the same way. Yeah, like the biggest thing is not how to make it work. It's what could go wrong and make this not work.
yeah,
Like okay, if I do this, what could potentially be the outcome of this change or whatever.
yeah, yeah. Do you think that like kind of gives you, I don't know, makes you doubt yourself, or does it kind of like, do you ever feel like that mentality is like makes you doubt yourself more?
Um, I don't. It's hard to say. Sometimes, yeah. I mean,
Yeah,
but it's like at the end of the day. I mean, you're like, okay, well, you check all that you can think of, and then obviously there's still going to be things that could happen, like with you guys, but you prepare for those by saying, okay, well, I'm just going to sit here over this hand over this e-stop, and like you
yeah,
guys did, and
yeah.
even though you were doing that, it was just such a quick like
Just
thing that there was just nothing anybody humanly could react to
hmm
to prevent. But
yeah,
yeah, I mean,
yeah. It sounds like a joke because it's like, I don't know. I'm a little bit ashamed to say to say this, but there's sometimes when I'm sitting there and I'll go through and I'm like, okay, I'm making this change. It's not changing anything that's like can cause a problem. But then when it works, I'm like, oh, hey, it actually worked. Dude,
yeah,
that's
yeah,
awesome. I'm like surprised. But then I'm like,
yeah,
I'm I've been doing this long enough that like I shouldn't have that reaction. But I
yeah.
don't know. I don't know about you guys. Like if you still have that sort of like experience of where it's like, I mean, for me, I've probably started up. If I've started up one Siemens drive, I've started up 1,000, and there's still this like pleasant like, oh hey, I downloaded it to it and it came up and it went green lights. Huh, that actually
Yeah.
worked. Huh.
Yeah, I think I had a lot of those moments working on those automatic recovery routines, especially. I'm like trying to get the sequence and all this, like get it where it'll go back into the sequence. That was a pain. And then I'm just like, oh wow, wow, it actually worked.
Yeah. What do you feel? What do you feel like was the hardest part of that? Like, uh,
Of
in
doing that programming.
yeah, in getting that, because I know you were like
Yeah.
jumping into the middle of it. Like, what was the hardest part of that?
I mean, just really figuring out how to get everything back in the sequencer without causing other issues. Because there's a lot of stuff. I know you showed some of it that has to happen, like the homing of certain axes and stuff like that to move on to the next step and all that. And there's so many conditions where, like, okay, well, if the home is not complete for a certain axis, then it won't move to the next step, that sort of thing. And just, I guess, kind of figuring out the best spot to put it in without causing any kind of errors. And trust me, I it took me several attempts to figure out the right spot to jump back in without causing some kind of technology object fault or something, like trying to home axis that was already in motion, or something like that, that would fault out the drive. But anyways,
Do you, do you what percentage of confidence do you have in what's implemented there? That puts you on the spot.
what do you mean?
I
Like,
was
you're saying,
just saying like so
like,
for
what's the
me,
code there?
yeah, so for me it's like even in like the code that we have like on the 2020 winder, I still it's taken it's almost 4 years it'll be running here in May, and there's still a part of me that's like, I think that might just fall apart
Yeah.
at any moment. There's like
um
it's probably only like 1%. So I'm like
there,
98,
Yeah,
99%.
there's been a couple of things I've gone and added to the program, and I'm like, okay, well, here's the off, like, switch on the HMI. So if it does something crazy, just turn it off.
Yeah.
Like,
Yeah.
yeah, I think the most of the stuff we've got out there though right now has been pretty thoroughly tested and seems
Mhm.
to be working well. I better knock on some wood, but I haven't heard from them in like 2 weeks. So no news is good news usually. So we
Yeah.
just we kind of have been improving. Just for anybody that's not aware, we've been still going out to the customer site and improving, add some features and stuff. And they're fully run in production now. But
Yeah.
for a while there, we were spending a lot of time. A lot of it was just operators, getting used to the new controls and all that. And
Mhm.
kind of once we got them set along, we haven't had to go out there a whole lot. And I think the last time I was there, I changed up the sheet break detection
Mhm.
a little bit, and I think I got a pretty good system there, for detecting that. And then we kind of tested it out, and it seemed to work pretty well. But I
Yeah.
was I don't know if you're looking at the recent version, but I think I don't even know if we really talked about it. I added basically on startup, it would just look at, I guess, I think it was for the first, I think it's time based. It's like first 2 seconds or something like that. And it'll just take whatever the peak velocity of the mandrel is. And like Jason explained, as that roll grows, since we're running in torque mode, the mandrel will start to decelerate because the roll is getting bigger. It doesn't have to run at the same speed to keep the same amount of torque on that motor. So basically, what I'm doing is just looking at the velocity of that mandrel. And so we get the peak velocity, and then we know it should constantly be slowing down as long as it's winding the roll.
Mhm.
And so if they have a sheet break, basically, obviously, that mandrel is going to speed up because the torque is going to go, or the tension is going to go away from the material. So it'll lose that torque and it'll try to speed up. So basically, I'm just saying, if it goes above whatever that peak torque is, which it happens pretty rapidly,
Mhm.
just from charting, then I say, hey, that's a sheet break, and shut it down. Where before we had a little bit of other logic that was kind of hit or miss. It would
Yeah.
cause a lot of false triggers as well every now and then.
Mhm.
Because I think it was based on like the speed set point. That's changing with the FPL mode and
Mhm.
a bunch of other stuff. So, anyways, I added that, and that was one of those things. They definitely have an off switch for it, but as far as I know, they haven't had to change it. And I watched it happen several times, and it seemed to be pretty effective. So,
Yeah. In
yeah.
that sheet break, are what are you doing, I guess, with the roll that's on the mandrel? How are you handling it?
Right now, we're just setting the alarm off and stopping it because, most of the time, if it's a sheet break, it's probably broken out back behind the winder, and they're going to have to physically intervene to kind of get the winder back running. So there's not really any kind of auto recovery or anything that can be done
Yeah.
in the event of a sheet break. But
Yeah.
best case it broke out like between the accumulator and the metering roll, and they can kind of just go in there and thread it back up. But worst case, it broke out in the back, and they've got to kind of do the whole process of threading the whole thing up again. But yeah, we're just setting off an alarm right now
Yeah.
because yeah, there's not really any kind of way to recover from that.
Yeah, that brings up an interesting point. That I kind of hear all the time. It's kind of getting off topic of the program. We'll probably, I mean, we're coming up on 2 hours of
Yeah,
of this, so probably wind it up a little bit. Talk about the code a little bit more if we have more questions. But um, one thing that I kind of get asked a lot is like, oh well, how do you see like these jobs get taken away and all this stuff and like how all this stuff? And honestly, when I first started, gosh, I was probably 14 years old or something like that. That I kind of was like, oh, I feel like we're taking away jobs and these people or livelihoods or whatever. But what do you see as kind of like the role the role of the people there that are there now? Because to me, there I don't ever see there being a completely like personless line, unmanned line. I mean, what are
yeah.
your thoughts on that?
No, I mean, I mean, advancements in technology, I think eventually could get there possibly, but I think there's always going to have to be somebody. Obviously, you got to have maintenance folks there, but then as far as like the workers that are maintaining the process and that sort of thing, like um, even the older winder they have there now, I mean, you still got to have somebody pulling off rolls. And which like we could probably automate that side of it, but as far as threading it up and stuff like that too, I don't know if we're quite there yet. Possibly could get there, but it's one of those things where it might be more of a headache than it's worth to just have somebody with the dexterity and ability to know the process to just do it.
Yeah,
um,
yeah, that's
yeah,
definitely
I think.
the thing that sorry to cut in. Like you said the word dexterity there. Um, I think a lot of people that have never seen this process or really any process, there's some stuff that is just incredibly difficult for a robot to do and or a machine to do. And there is like machine vision and like offset corrections and stuff, and all of or a lot of the alpha team has experience with some form of robots. We have ABB robot experience, but a lot of that is like you're point to point. You you're following a path, and then you can set offsets. You could set a little bit of change, and ultimately there's gonna have to be somebody there, and then there's gonna have to be somebody there to, like you said, maintenance on stuff. And so I I also realized like very early on that a lot of the it's really enabling better jobs at these places. And while there might be some just like pure manual labor jobs that are getting taken away, most of the time those are high turnover anyway. People don't want to be in those positions. Um,
Yeah. And
they're
I'll mention with that,
yeah.
like, one of the biggest things at my other job we kind of justified robotics for is not to get rid of people, but actually ergonomics, like,
Mhm.
to kind of prevent injuries and that sort of thing. Because, like you said, there's a lot of manual tasks that are repetitive, that people are prone to injuries on. That's kind of where robotics shine, and focus less on taking jobs away and more improving quality of life for those doing those jobs. And there's always going to have to be people there, I think, to kind of keep the process moving along. So
Yeah. Um, yeah, it's kind of like in it's like who wants to make a career of setting finished product on a pallet anyways? Because I mean that
yeah,
I don't think that is a career. And I mean I think 2020 kind of jaded me a little bit in terms of like what people do with free time. Um, but also at the same time of like there is there is still like innovation in people, and like if we could take away those, or if we can take away those mindless jobs, it's eventually just going to like wear someone out and hurt them. Like I see that as a net positive. Even if later on that person that is stacking rolls on a pallet, like they they have such more opportunity to do other things with that, and that, I guess, maybe that's one of the things, is like that's on them at that point. And um I I was talking to someone about one of our other options that is definitely going to have to be for another stream, but talking about trying to bring actual neural network artificial intelligence onto these plant floors where it makes sense. And they were like, well, how many jobs is that going to take away? And I'm like, well, these are already in plants that, if they're there, you're you're almost killing you're almost like killing people by having them there. Like at some of these, like at a coal mine, for example, the lung quality and the silicates and just like particulars in the air that you're exposing people to, that if you could take them out of those environments, dusty environments, high heat, like you're you're causing you're causing not causing you are the process itself in order to produce this product is putting people in these places that's like they probably wouldn't go. Like
Yeah.
these most of these environments, uh you had it worse. Like I would not want to be sitting there again in the summer. Like this was like the oh my goodness, starting this up in, what was it, uh June and July.
Oh yeah,
It
yeah.
I like air temperatures were over 100 or 110 degrees at this place. And in some of the places the air temperatures were up in the 120s, because this is like molten tar. And to be able to get people out of those environments, yeah, they're still going to have to be there when stuff messes up, but just to be able to remove them from these difficult environments, I think is kind of a bit of a responsibility for if we are able to do that, to do that. But yeah, um there's all of this talk about automation being the end of like society, and like we're gonna have to figure out like the post-industrial revolution. And I don't know about you, but there's I kind of have faith in people, that there are enough people that are innovative, that will and take that time and do something better with it. Even if it's something creative. Like if that enables someone to do something creative, like this podcasting, TikToks, whatever. As much as I want to like my boomer mindset of like, oh, this is just rotting people's mind away or whatever. Um, like there is something for that creativity, and to be able to do that, and you see creativity in a lot of different ways. But yeah, um, so on this project, we're kind of gonna wrap it up like for this, and we might answer some other questions about this in another time. Is there anything like that you would like to highlight on this project from a programming perspective, or something that you were exposed to that you think either a that you learned on this project that you would like to like take to, say, someone that's asking questions of like going into college, and like, hey, what do I want to do? Is there anything on that like you could apply from this project?
You put me on the spot
Oh
there.
yeah, yeah. I probably should have put that one in the Discord before.
I know. I needed. Yeah, you should have teed me up for that one. No. I mean, as far as like the project goes, I think the biggest thing for me, like learning, was just a lot to do with interacting with the technology objects in the Siemens side and that sort of thing.
Mhm.
But as a whole, just kind of like, doing this whole project from the ground up, most of my experience had been just in the control side and kind of getting to interact with the guys doing the mechanical build and all that too, while we were kind of doing the control implementation as well was a neat side of it. So, you know, for anybody, I would say to kind of keep an open mind. And one thing I wish I'd done more of going into school was, take some more mechanical classes to kind of understand that, because there's so much that goes into controls outside of just programming. You kind of to do what we do, you kind of got to know a little bit of everything. You got to know a little bit about pneumatics, a little bit about just mechanical, like bearings and motors and stuff like that. So I think if you're wanting to do this type of work, kind of keeping an open mind and learning a little bit of everything would definitely improve your ability in the future.
Mhm. Yeah. Well, I personally nerd out on all this stuff. And so like I love talking about it. I love talking to people about kind of the opportunities. And again, I take for granted the fact that like most people have never seen this type of stuff. And to be able to see a video like we showed earlier, and hopefully we'll be able to figure out ways to integrate more into this channel and to kind of like spread those things of like, hey, here's actually what we're doing. Um, and I
Yeah, I think
know,
you could probably do some shorts, couldn't you? Like that'd be some cool stuff, like the
yeah, that
shorts.
definitely some
Maybe like
shorts
put
that,
the winder and stuff up there and
hmm
some stuff like that.
yeah, and I've definitely thought about that. I mean, there's a
Show
little
some
bit,
chickens riding conveyors up in,
yeah. Oh yeah. There's going to be a whole series on like
be
the
up there for a
this
couple months. You get plenty of chickens riding up the conveyors up to where you're at.
yeah. So this new project, we're it's kind of, it's a little bit morbid, but then it's like it's also just kind of a fact of like the nature of it. This plant up in Illinois is a fertilizer plant that's taking chicken litter, um affectionately known as chicken litter, and off of an egg laying hen house. And so uh, every now and then, apparently, um, a bird would pass out from like getting too hot or whatever, or just kind of like fall asleep or whatever, and end up on the belt. And so you had these birds that would just kind of be like end up walking around in the shop. And so that's kind of what or at the fertilizer plant, that's what he's kind of talking about, riding the belts out. And the worst part about it is like they had their freedom and they chose to go back. They chose to go back and like walk around the plant. They're right next to this huge like cornfield, and no, they choose to walk around the parking lot.
Yeah.
Like so, but yeah, I think we'll try to get some more shorts of funny stuff, and a little bit more of the life. Like I personally think like what's over in the shop right now. So uh, just so y'all know, Brandon is the CTO of Alpha, and so he's really in charge of all of the technical execution of our projects. And while I might come up with a bunch of harebrained stuff, ultimately it's up to him to give the like go no go on stuff, because as I always say, like you're the one that's going to be building the stuff, and so I let him make the decisions. And I'm sure that he's sitting there thinking like, oh yeah, well, do I really have a choice? But
Uh,
our shop right now is absolutely full with a really big project up in the Midwest again, and it's one of these fertilizer plants. And I feel like we're about to take it to the next level, and we're definitely going to talk about it in the next one. We've been going for 2 hours now, uh, and for a first, I guess it's not our first live stream on this, but for our first AlphaCast, I think that's pretty good. And we're
yeah.
we're gonna. You have any parting things before I give the whole like and subscribe and like YouTube stuff?
No, I appreciate you having me on. Look forward to doing more of these, and maybe we can kind of get some feedback from people watching the channel, and see what people would like to see if there's some ignition stuff, and then we're obviously going to do some stuff that we have done as far as like the integrating with Siemens and stuff, and some of the other ideas, and then we can kind of go from there. And you know, I think doing some shorts would be a cool idea too. Kind of show what we do and get some more interest in the programming behind it and that sort of thing.
Hmm. Yeah. Well, I'm looking forward to it. This was fun. I know we've talked about doing this for so long, and I don't know. I could just talk about it. It's really hard for me to put together the videos, and like the only way that the past couple months has been having the success that this channel has had is because my wife Kiki has been doing so much to like get those videos out, because my goodness, I do not have time to edit videos. Um, like the past like 6 months have been just wide open, and yeah, we have been very much blessed, and so we want to try and like bring that we want to bring that same energy into anybody that's like wanting to get into this. And there's such an opportunity here, and I mean, not everything should be about money, but I mean, let's be real. When your bills are taken care of, it's nice. When you can afford to have some toys, like it just it makes life a little bit easier to live. And one of the things about automation is if you get that bug and you get like moving into that and like really understand that it's more than just like chat gpt and that sort of stuff, that there's this massive world of just really everything. Hopefully we'll be able to kind of go through and talk about different projects. Maybe we could bring some people on that have different experiences. I know we've got some of our partners that have a lot of like wastewater experience. We have partners that we work with that are in pharma and all these different things that have widely varying degrees and educational levels and experience levels. And so hopefully we'll be able to use this call it a podcast, whatever you want to call it, as conversational, but also educational. Um, and maybe we'll get some like shorts or something. Maybe we'll do some clips out of these in order to chop it up. But yeah, if you're watching this on the VOD, um, you have any questions, feel free to send those comments, because I mean, and always like the video. The one There's one live stream that I did about technology objects that kind of got this channel out there and moving, and it's running up on about 10,000 views, and in the grand scheme of the YouTube, that's no views. I mean, Mr. Beast and like all these, like whatever. But I feel like, I don't know about you, Brandon, 10,000 views on a dry like automation video talking about some like technical random video. I feel like that's worth like singing praises about for you guys to be able to like put that stuff together. And y'all that are like at the start of this, hopefully you get to take a part in something that grows to bigger. We're should probably by the end of the week hit that 500 mark. And if you have any idea about like YouTube, 500 subscribers is like the bare minimum for a channel. And so we're about to hit that milestone, and we're not looking to make any money off of this. We're looking to just reach more and more. But once you start hitting those milestones, hopefully these videos will start getting out there to more of you guys. And yeah, so hit that like button, and that's the best. Liking and commenting is the best way to get these videos out there, and we're gonna keep doing them. I don't know about you, Brandon. Like, if as long as we have time to do stuff, I want to
Yeah,
keep doing these things.
shoot for at least either every week or once every couple weeks at a minimum or something.
Yeah, maybe we'll start doing these like on another night. Yeah, yeah. Comment in the comments about if you're watching this. What would be a good time to watch this? We finally have enough data that I see when the most people are watching it. and it seems to correspond to kind of the morning of Sunday. So like 8 o'clock Sunday morning, and I do not know why people would be watching technical videos on a Sunday morning. I guess if you've been working all weekend on a problem and you've given up all hope, you start watching this channel. Is that what it is?
Take the Saturday off and yeah, get back on it on Sunday.
Yeah, yeah. But anyway, I appreciate you, Brandon, and not just this podcast, but all that you've done and the energy you brought into Alpha. And I think you know this, or at least you should know this, that you're an integral part of this growth to the company. And yeah, hopefully you'll be part of the growth of this channel too.
Yeah, that'd be
Um,
awesome, man.
yeah. So anyway, without further ado, we're going to close up the stream, and yeah, I hope y'all all have a great evening, or I guess you might be watching this on later during the day. But yeah, y'all take it easy. Like, subscribe, ring that bell so next time we go live, might be at some random time. Maybe you're on, and if you're have that notifications on, you'll get served up with it. But anyway, thanks for tuning in, and as always, keep on learning.